Alright guys, welcome to Unit 2. I hope everyone did well on the Unit 1 test and you're ready to start learning about the atom. And it kind of starts off with an interesting lesson here, not so much chemistry, honestly, as it is a history lesson, which is important to understand where we're at with our knowledge of chemistry today. So this lesson goes over the history of the theory of the atom and kind of how it started and how it evolved into what it is now. So it started. The idea of an atom goes back around 2,000 years to Democritus, and he was wondering, hey, can we divide everything into infinitely small parts, or is there going to come a point in time where we have the smallest of the small, where it's indivisible, where we cannot divide something up any farther? And so that was what he proposed would be called the atom. So then we kind of stayed that way for a long time, just thinking about the atom as this undefined part that cannot be divided any further until we get to the 1700s, and then Lavoisier, this French chemist, he did some experiments and he learned that basically matter cannot be created or destroyed. He showed that chemical reactions showed that matter was neither gained nor lost in a chemical reaction. So he did these chemical reactions and the reactants equaled the products. There was no matter created and there was no matter destroyed in these reactions. Then in the 1800s we get John Dalton, he's an English guy, and so he comes up with this atomic theory of matter that have four main points. He says all matter is made up of atoms. Atoms are very small and indivisible, which we already established a long time ago. All atoms of a given element are identical in mass and chemical properties, and then chemical compounds form when two or more kinds of atom combined. And then he suggests that chemical reactions happen when the atoms combine, separate, or rearrange, but the atoms don't change identity themselves in the process. So we have these atoms, they're not changing identity, they're just combining or rearranging to make different compounds in chemical reactions. And so Dalton also described, or he hypothesized, that all atoms of one kind of element were the same. And that's kind of a big step here. So we're saying that if we have, like, this is a gold atom, it equals another gold atom. That's what Dalton is saying. He's saying gold equals gold, right? But he's saying that if we have a gold atom, it would not be the same as a silver atom. Does not equal silver atom. He doesn't know what's different about them yet, but he's saying that, hey, you know, one element, those atoms must be the same, but they're not the same as other elements. Now, up until now, we're thinking that an atom is just a single tiny particle, but in the late 1800s, J.J. Thomson says that way atoms are a little bit more complex. They're not just one particle. Atoms are actually made up of even smaller particles. And so he's the one that did the cathode ray tube experiment, where basically he discovered that electrons have a negative charge, right? So he had this tube. So he had this tube here, and it kind of was like, it's like this or whatever. And so he had some plates here, and he had, maybe this would be like the positively charged portion, this would be the negatively charged portion, and he shoots this beam, this is some gas down this tube here, and the gas, it goes a little bit this way, maybe towards the positive end, or I think he had something here. It's like positive, negative, and so he finds out, he shoots something through here, and the gas bends a little bit towards the negative end, and he hypothesizes that there must be some sort of negatively charged particles within the atom, right? Because negative is attracted to positive, so if there's some negatively charged something in this gas, it's going to be attracted to the positive side and repelled from the negative. So he's saying, hey, there must be something in these atoms that have a negative charge, which we now know are electrons. So then he did his experiment with other gases to see if all atoms, no matter what the element, if they all have these negatively charged particles, and of course he did, because as we know now, all atoms contain electrons. So any gas that he shot down this cathode ray tube would be displaced, would move towards the positive a little bit, because they all had electrons. And so, as I said a minute ago, this was really important because until now, people thought that an atom was just one big mass. But now we know that an atom is made of even smaller particles. It's not just one big mass, it has smaller particles in it. And so his model, Thomson's model of the atom, Thomson's atom looked like this. He was called the plum pudding model. So he's like, oh, here, this is a bunch of positively charged substance, and then he said there's little negatively charged particles within this positively charged substance. So this was his model of the atom. Obviously, this is not what atoms are. We know today that there's a nucleus, there's protons and neutrons in the nucleus, and electrons outside the nucleus. But right now, this is what Thomson thought, and this was a big advancement at the time. So then this lesson stops with Robert Millikan, who wanted to determine the mass of the electron. Thomson was able to determine the charge of the electron, but now he wanted to determine the mass of an electron. And this was important because knowing the mass of the electron, he found out that it was really small compared to the atom as a whole. And so, we knew then that there was a lot more to the atom, or at least a lot more mass to the atom than just the electrons, and that leads on to further experimentation, which I think we get to in the next lesson.